Section 5.4. Here we're going to be using identities. Some identities you already know is cosecant theta equals 1 over sine theta. That's how we were finding cosecant theta before. It was the reciprocal of sine. Secant theta is the reciprocal of cosine theta. And cotan theta is the reciprocal of tan theta. Well, that also means that sine theta is the reciprocal of cosecant theta. Or cosine theta is the reciprocal of secant theta, and tan theta is the reciprocal of cotan theta. So if we're simplifying or solving for sine theta, and we're given cosecant theta, well, since cosecant theta equals -2, then we know sine theta is going to be the reciprocal of that, which is going to be 1 over -2, or a -1/2. Find cosine theta given secant theta equals the square root of 11. Then cosine theta equals 1 over the square root of 11. But we have to rationalize this, so times the square root of 11 over the square root of 11, and we get the square root of 11 over 11. Find tan theta given cotan theta. So tan theta is going to equal the reciprocal of cotan theta. So it's going to be 2 over the square root of 5. Then if we rationalize this, square root of 5 over the square root of 5, so we're multiplying by the square root of 5 over the square root of 5, and we get 2 square roots of 5 over 5. So those are the reciprocal identities. Something else that's very valuable when we're doing trig is the signs of our functions. If x is, now notice r is always greater than 0. R is always going to be positive. You can think of that's going to be our hypotenuse. Now in the first quadrant, x is positive, y is positive. So all trig functions will be positive, because a positive divided by a positive is positive in the first quadrant. In the second quadrant, x is negative, y is positive. So sine, because it's y over r, is going to be positive, and its reciprocal, cosecant, is r over y. So that's going to be positive. So sine and its reciprocal are positive. The other 4 trig functions, cosine, secant, cotan, and tangent, are going to be negative. In the third quadrant, x is, so you have to go back and down, so x is going to be negative, and y is going to be negative. Tangent is y over x, which is a negative divided by a negative, so that's going to be positive, and its reciprocal, cotangent, positive. The other 4 are going to be negative. So in the third quadrant, it's going to be tangent and its reciprocal. In the fourth quadrant, x is positive, positive direction, y is negative. So x over r is cosine, positive over positive is positive. Sine is y over r, negative over positive is negative. And tangent y over x, negative divided by a positive, is negative. So cosine is the only one, and its reciprocal are the 2 positive ones in the fourth quadrant. The other 4 are negative. Now a way to remember this, all sine is reciprocal, tangent is reciprocal, and cosine is reciprocal, is remember saying all students take calc, and that should help you with the positive functions. All positive, sine, students, sine and its reciprocal, take tangent and its reciprocal, calculus, cosine and its reciprocal, when you're learning those signs as you go around. So now if we're looking at the signs in the first quadrant, all are positive. In the second quadrant, so remember your sine is going to be positive and its reciprocal, cosecant's positive, which means the other ones are negative. In the third quadrant, its tangent's positive and its reciprocal, cotangent, the other ones are going to be negative. And in the fourth quadrant, its cosine is positive, and its reciprocal, secant, the other four are going to be negative. So notice the first quadrant you have 6 positive, the second 2 positive, 4 negative, third 2 positive, 4 negative, and the fourth 2 positive, 4 negative. So whenever you're checking your values of your trig, make sure you check your signs to make sure the signs are correct. 150 degrees is going to be in the second quadrant, so it's a negative x, positive y. And if you want to determine the signs of the trig function, since we're in quadrant 2, so it's going to be the same as up here. Your sine is positive, so if we want, we could say sine theta is going to be greater than 0, positive, and cosine theta is going to be less than 0, negative. Tan theta is going to be less than 0, negative. Cosecant theta is the reciprocal of sine, so that's going to be positive. Here's our positive, positive. The other, secant theta, less than 0, and cotan theta going to be less than 0. So we have 2 positive, 4 negative. Negative 150 degrees. So remember, negative is that direction going this way, 150 degrees. So we're in the third quadrant. So if we're looking for our trig functions again, cosine, sine theta, cosine theta, tan theta, cosecant theta, secant theta, and cotan theta. In the second quadrant, cotan theta is greater than 0, and tangent's greater than 0. So again, tangent theta is greater than 0, and cotan theta is greater than 0. Tangent and its reciprocal in the third. All the others are going to be less than 0, less than 0, less than 0, less than 0. These are going to be negative. So tangent and cotangent are the only 2 positives in that third quadrant. So here would be theta, and here would be theta in that. So now if we're looking for identify the quadrant, where is sine greater than 0? Where is sine positive? That's in 1 and 2. Where is tangent negative? That's in 2 and 4. It's positive in 1 and 3. So where are they both true? In quadrant 2. Cosecant less than 0 is saying sine theta is less than 0. Secant greater than 0 is saying cosine theta is greater than 0. So where is sine negative? In quadrant 3 and 4. Where is cosine positive? 1 and 4. Where are they both true? In quadrant 4. Where sine is negative, cosine is negative. So sine's negative in the second. Sine is negative in the third and fourth. Cosine's negative in the second and third. Where are they both true? In the third. Cosine's positive, and tangent is positive. Cosine's positive in 1 and 4. Tangent's positive in 1 and 3. Where are they both true? In quadrant 1. So after sines, we want to discuss the ranges. What are the possible values that we get out from these trig functions? So for sine theta, cosine theta, the range is going to be that it's the absolute value is less than or equal to 1. And what that really says is the range values are going to be between -1 and 1. So sine theta and cosine theta is going to be greater than or equal to -1, but less than or equal to 1. tangent and cotangent, the range is going to be all real numbers, negative infinity to infinity, and the reciprocal of sine and cosine is going to be between negative infinity and negative 1, and from 1 to infinity. It does include 1 and negative 1, but nothing in between. So if we want to determine if cosecant theta equals 1/2 is possible, well, cosecant theta has to be greater than 1 or less than negative 1. So this is not possible. If we were to look at the sine theta, that's the reciprocal, is going to be 2. This is saying sine theta is between negative 1 and 1, and 2 is not between negative 1 and 1, so it's not possible. So we could get it from the cosecant, or we could get it from the sine. Tan theta, what's that saying? Negative infinity is less than tan theta is less than infinity. That's what this all real numbers is. So negative infinity is less than 6, negative 6 is less than infinity. This is possible, because negative 6 is between negative infinity and infinity. Cosine thetas equal 1. Cosine theta can equal 1. It goes cosine theta is between negative 1 and 1, but this is saying it can equal, it can include. So this is possible. Sine theta equals square root of 3 over 2. Well, again, that's saying is sine theta is between 1 and negative 1. Is negative 1 less than or equal to the square root of 3 over 2 less than or equal to 1? The square root of 3 over 2 is approximately 0.866, which is between negative 1 and 1. So this is possible. Soon we'll actually find the angle that will give us the square root of 3 over 2 on sine. So now we have some identities. So this is the Pythagorean identity. If you remember, we had x squared plus y squared equals 1 on our unit circle. And on our unit circle we said that x is the same as cosine theta and y equals sine theta. And again, that's a unit circle when our radius is equal to 1. Then if you substitute these in, x is going to be your cosine squared theta plus your y is going to be sine squared theta will equal 1. To find these other Pythagorean identities, we're going to need the quotient identities, which is tan theta is the same as sine theta over cosine theta, and the reciprocal of that, cosine theta over sine theta, equals cotan theta. So if we come over here and divide everything by cosine squared, so if we have sine squared theta over cosine squared theta, sine over cosine is tangent, so this is going to give us our sine squared over cosine squared is tan squared theta. Cosine squared over cosine squared is 1, and 1 divided by cosine squared theta equals 1 over cosine is secant, so 1 over cosine squared theta is going to be secant squared theta. And similarly, to come up with this identity, we can start with our main identity, and this time divide by sine squared theta. Sine squared theta over sine squared theta is 1. Cosine squared over sine squared, well, cosine over sine, so cosine squared over sine squared is going to be cotan squared, and 1 over sine squared is cosecant squared. So now, how are we going to use these identities? We're going to use them to find all, given some information, we're going to find the remaining trig values. So for example, if sine squared theta plus cosine squared theta equals 1 and sine equals 2/3, we're going to be able to find cosine theta. So notice this is an equation with one unknown, so we can solve this. This is 4/9 plus cosine squared theta equals 1. Cosine squared theta equals 1 minus 4/9. So cosine squared theta equals 9/9 minus 4/9. It's going to be 5/9. So cosine theta is going to equal plus or minus, it's positive or negative, the square root of 5/9, which is plus or minus the square root of 5 over the square root of 9, which is plus or minus the square root of 5 over 3. Now that plus or minus, it's important to understand that plus or minus depends on quadrant. So if cosine's in the first quadrant, then it's going to be positive. If cosine's in the second quadrant, then it's going to be negative. If cosine's in the third, it's going to be negative. If cosine's in the fourth, it's going to be positive. Since we know we're in quadrant 2 and cosine's negative in quadrant 2, our cosine's going to be negative square root of 5 over 3. So what we know so far is we know sine theta equals 2/3. Now we have cosine theta, we know is negative, because we're in the second quadrant, square root of 5 over 3. Now if we had tan theta, we'd be able to find the other 3 by using our reciprocal identity. So since we know sine and cosine, tangent is sine over cosine. So this is tan theta equals sine theta, which is over cosine theta. So tan theta equals sine theta is 2/3 over cosine theta, negative square root of 5 over 3. So what do we get now is 2/3 times, when you divide by a fraction, you're going to multiply by the reciprocal. So it's going to be 3 over negative square root of 5. The 3's cancel. And we get, so this equals negative 2 over the square root of 5. And now we're going to have to rationalize that. So multiply by the square root of 5 over the square root of 5. And we get negative 2 square roots of 5 over 5. Negative 2 square roots of 5 over 5. So now that we have sine, cosine, and tangent, we can get cosecant, secant, and cotangent. Cosecant is the reciprocal of sine. So we get 3/2. Secant is the reciprocal of cosine. So we're going to get negative 3 over the square root of 5, which rationalizes to negative 3 square roots of 5 over 5. And then cotangent's the reciprocal, but I'm going to go before I rationalized it. So this is going to be negative square root of 5 over 2 will be that reciprocal. So we can use these identities to find all 6 trig functions. Now let's do one more. So again, if we're saying x squared plus y squared equals our unit circle, from that we can get the Pythagorean identity, which our x is going to be cosine theta, so it's cosine squared theta plus sine squared theta equals 1. Cosine's negative 3/5 squared plus sine squared theta equals 1. So I can solve this for sine theta. 9 over 25 plus sine squared theta equals 1. Sine squared theta equals 1 minus 9 over 25. Sine squared theta equals 25 over 25. 25 minus 9 is 16 over 25. So sine theta equals plus minus the square root of 16 over 25. But because we're in quadrant 3, we know sine theta is equal to negative in quadrant 3. And the square root of 16 is 4. Square root of 25 is 5. So there's our sine theta. So we know cosine, or if I do these in order, just out of habit, starting with sine, sine theta equals negative 4/5. Cosine theta equals negative 3/5. So I'm looking for tan theta. Well, tan theta equals sine theta over cosine theta, which is equal to negative 4/5 over negative 3/5. So we're going to get negative 4/5 times the reciprocal, 5 over negative 3, and we get positive 4/3. Negative over negative is positive, and the 5's cancel. So we get 4/3. But in the third quadrant, that should make sense that sine is negative, cosine is negative, so tangent has to be positive because there's 2 positive and 4 negative. And if we do the reciprocals, cosecant theta is negative 5/4, secant theta negative 5/3, and cotan theta is equal to 3/4. So we can find all 6 trig functions given 1 and a quadrant, and using these identities we can find all 6 trig functions. Now we could continue with that, but we could do it again. Let me actually go back. Get another piece of paper here. I want to go back and let's do the last one we just did. Okay. So if I'm going to do this again, this time instead of using identities, we can actually, if we can get our triangle, our diagram, with the correct sides, we can get all 6 that way as well. So notice, instead of using identities, if I know I'm in quadrant 3, so here's my triangle, always going to the x-axis, and here's theta. So even though theta's that angle, I can use this right triangle in the third quadrant as my reference. Now cosine is going to be x over r. So I know this is negative 3, which makes sense because we got to go back. And this is 5. So that's my adjacent over hypotenuse, or x over r. How do we find this other side? Well, it's going to be negative 3 squared plus y squared equals 5 squared. 9 plus y squared equals 25. Y squared equals 16. 25 minus 9. Y equals plus or minus the square root of 16. So y equals plus or minus 4. But again, this depends on the direction now. Since we're going down, this has to be a negative 4. Now, once I have my x, my y, and my r, I can get all 6 trig functions that way as well. So sine theta is y over r, or opposite over hypotenuse. negative 4/5. Cosine theta is adjacent over hypotenuse, or x over r, which is negative 3/5. But remember, that was the one that was given. And tan theta is y over x, or opposite over adjacent, negative 4 over negative 3, which reduces to 4/3. Now we can do the reciprocals. Cosecant theta, secant theta, cotan theta. So we get negative 5/4, negative 5/3, and 3/4. And again, once we leave that first quadrant, notice 4 negatives, 2 positives. But notice those answers. We have the same answers for sine, cosine, tangent, cosecant, secant, cotangent. So one is using identities, the other is using your diagram, your reference triangle, to find all 6. It's going to be, you'll need to know some identities and be exposed to identities, but if you can get all 6 this way as well, once you have your picture, but you have to be able to decompose what this is really giving you in the quadrants. If you can't, then you're going to have to use the identities. So we have quite a few more examples to run you through. So if we're looking for sine, tangent, you could use identities. I'm going to draw a picture. Sine is positive, cosine is negative. That's going to tell me quadrant 2. Cosine is x, negative square root of 3. R, 4, so that's over r. I need to find my other side. So negative square root of 3 squared plus y squared equals 4 squared. 3 plus y squared equals 16. Y squared equals 13. Y equals plus minus the square root of 13. But because I'm going up, this is going to be the positive square root of 13. My theta's here. That would be a reference angle. So my theta's here. This angle between the terminal side and the x-axis, that would be your reference angle. But what is sine theta? It's y over r, or opposite over hypotenuse, square root of 13 over 4. And tan theta equals y over x, or opposite over adjacent. But we have to rationalize this, times the square root of 3 over the square root of 3, and we get the square root. You can multiply these, square root of 39 over negative 3. So here's our sine, here's our tangent. And if this problem asks for more, if we had cosine, sine, tangent, we can get the other 3 as well. But you could get these by using your identities. But if you can decompose this into your triangle, your reference triangle, then you can get everything that way as well. Find sine and cosine. Tangent's negative, quadrant 4. Tangent is y over x, positive x, negative y. So this is going to be negative 4. This is 5. But also think of it as opposite over adjacent. We need this other side. It's going to be the 5 squared plus negative 4 squared equals r squared. 25 plus 16 equals r squared. R equals the square root of 41. Now it really is plus or minus, but the hypotenuse is always the positive. So square root of 41. My theta's coming around. That could be theta, or I could have a negative theta if I was coming down. But sine theta is y over r, or opposite over hypotenuse. Negative 4 over the square root of 41. or which rationalize the negative 4 square roots of 41 over 41. Cosine theta equals x over r, or adjacent over hypotenuse, 5 over the square root of 41, which equals 5 square roots of 41 over 41. But again, take the time to check. In the fourth quadrant, sine is negative and cosine is positive. So take the time to check your signs as you go through. So more examples. If tan theta equals 3/4 in quadrant 3, so quadrant 3, so its tangent is opposite over adjacent, so it's going to be 3/4. But we have to be careful. Even though this reduces to positive 3/4, we went back and down. This is really a negative 4 and a negative 3. So negative 4 squared plus negative 3 squared equals r squared. Notice I'm using parentheses. So this is going to be positive 16 plus positive 9 equals r squared. 25 equals r squared. 5 equals r, plus or minus, but remember it's the hypotenuse, which is positive. Here's theta in standard position. So if we want the remaining trig functions, sine theta, cosine theta, tan theta, cosecant theta, secant theta, and cotan theta. So sine is y over r, or opposite y over r, or opposite over hypotenuse, negative 3/5. Cosine's adjacent over hypotenuse, or x over r, so it's negative 4/5. And tangent opposite over adjacent, or y over x, which is negative 3/4, which is reduces 3/4. But remember, that was the one that was given. And then 1, 2, the other 3 are the reciprocals. Negative 5/3, negative 5/4, and positive 4/3. So depending on which way, if you like identities or you like drawing your diagrams, your triangles, I'm going to do just 2 more examples. This one I'm going to use, I'll do a picture with this one. So we're in quadrant 2. Back, so that's going to be negative 8. Hypotenuse always positive. So now, negative 8 squared plus y squared equals r squared as we go through. So we're solving for that Pythagorean. So this is 64 plus y squared equals 17 squared, which is 289. So if we solve for y squared equals 289 minus 64, which is 225. Y equals plus minus the square root of 225. Because we're going up, it's going to be positive. So y equals the square root of 225 is 15. Positive 15 since we're going up. Here's theta. So sine theta, cosine theta, tan theta, cosecant theta, secant theta and cotan theta. Sine theta is y over r, 15 over 17. Cosine's x over r, negative 8 over 17. Tangent y over x, or opposite over adjacent, negative 15 over 8. Doesn't matter where the negative is. Cosecant 17 over 15. Cosine is negative 17 over 8. And cotan is negative 8 over 15. Okay. So, again, you could do this by the identities or have your triangle and get all 6 that way. The choice is really up to you at this point, but I do want to expose you to some identities as you're going through to solve. Quadrant 4. So if we start out, sine theta, cosine theta, tan theta, cosecant theta, secant theta, and cotan theta. So secant is 13 over 5, which means cosine is 5 over 13. And if we know that, we could do our picture. Cosine is 5, 13. We have to find the other side, which as you go through it is going to be 12. This is a nice triangle. Because we're going down, it's going to be negative 12. So you could use this, or I'm going to use an identity one. Cosine squared theta plus sine squared theta equals 1, since we have cosine. 5 over 13 squared plus sine squared theta equals 1. 25 over 169 plus sine squared theta equals 1. Sine squared theta equals 1 minus 25 over 169. Sine squared theta equals, this is going to be 169 over 169 minus 25 over 169. So we're going to get, that's 144 over 169. So sine theta equals plus or minus the square root of 144 or 169. Sine theta in this example, again quadrant, sine is negative in the fourth quadrant, so this is going to be negative. Square root of 144 is 12 over 13. So this is negative 12 over 13. So hopefully you can see that it's really two different methods. It's one, if you can decompose and get your diagram, your triangles here, we could see that the sine of theta, we can use this. So this is my theta, this would be my reference angle. But sine is going to be y over r. Notice that negative 12 over 13. Negative 12 over 13 if we use our identity. Now if we're doing tangent, so tan theta equals sine, which is negative 12 over 13, over cosine, which is 5 over 13. This is negative 12 over 13 times 13 over 5. Those cancel, and we get negative 12 over 5. And again, if we look at this, y over x is tangent, or opposite over adjacent, and notice we get that negative 12 over 5. Then the reciprocals, negative 13 over 12, and cotangent is going to be negative 5 over 12. So you can use identities, you could use your diagram. If you remember what each trig function is, y sine is y over r, or opposite over hypotenuse. Cosine x over r, or adjacent over hypotenuse. and tangent is y over x, or opposite over adjacent. Now I have 3 more examples on these notes that I want you to work on. I'm not going to do them on the video. I want you to try them. But if you go back and print the classroom notes, I did do them out. Okay, and they'll be in the notes, lecture 5.4 answers. I hope that helps with section 5.4.